Hello friends, welcome to Crack Kit CSE, and in this series of database today we are starting a new chapter, that is introduction of ER diagram. So according to the syllabus, so this is the syllabus, we have completed these 5 chapters like introduction of database, integrity constant, normalization, normal form and queries. So these 5 chapters has been completed, and if you have not checked any of these chapters, go to the playlist and you can easily find out the videos over there. So now today I am starting with a new chapter, which is the chapter 8. So I am starting with this particular chapter 8, and later on I will be moving on to this chapter 6 and 7, right? So chapter 8, this chapter is comparatively easy chapter, so that's why I am starting this chapter first, right? So if you have not subscribed to the channel, please subscribe the channel and press the bell icon so that you can get an update whenever I am uploading a new video. So now let's start with the introduction of ER model. So first thing is, what is ER model? See, ER is the definition. So ER is the abbreviation form of entity relationship. So it always defines the relationship. So this is what it says. ER diagram or entity relationship diagram is used to represent high level database design. So what is the meaning of high level database design? So if we are designing any conceptual or logical database, it is known as the high level database design or the diagrammatic representation of database design. So this ER model is very important when we are trying to designing database. So let's try to understand this with help of steps in database design. So what are the steps in database design? First step is requirement analysis. So first we have to check the requirement, because as per the requirement or as per the operation that the client is trying to perform on a database, we have to design the database. So first of all, we will take the requirement from the client, then we will try to formulate that how it is possible to meet the client's requirement. So what we'll be doing, we will be conceptualizing and designing the logical database. So here we will be trying to find out that how the tables and the relationship has to be made between those tables. So these two steps are under the high level database design, and ER is the part of that. So this particular second point is completely on the basis of ER model. So here we will be designing the ER diagrams, and in the third step we are converting those ER diagram into relational database models or RDBMS tables, and then after transforming those ER diagrams into table, we will be applying normalization to reduce the redundancy or to remove the redundancy, right? Next we will be implementing the schemas and creating index. So that's why I'm starting this particular chapter first, because after this particular chapter we will be starting with the indexing, so that we'll be having a clear idea that what is the part that we have to follow, right? Now what are the main components of ER diagram? So there are 3 main components of ER diagram. One is attribute, another one is entity. Entity is nothing but an object, and the relationship set is the relationship between the attributes or the entities. Now let's see the attribute. What is attribute? Attributes is a column or a field which defines the properties of the entity type. For example, I am having a table of car. So for that car, let column attribute is color. So if a car is having blue color, then I will be mentioning blue under that particular column, or if it is red, I will be mentioning red under that particular column. So this color defines the attribute or the properties of that particular car, right? So in ER diagram, this attribute is represented by an oval, or you can call it as ellipse. So this is the syntax, or this is the representation of the attribute name, right? So these attributes are of 4 different types. What are those? One is key attributes. So if any of the name written inside this particular oval is underlined, that is known as the key attribute, and this particular key attribute will be able to identify the uniques of a particular table, records of a particular table uniquely. So this key attribute is used to uniquely identify the records of a table. Second is composite attribute. So this composite attributes is a composition of multiple attributes. So this, you can see that this particular address is formed using the house number, city, country and state. So these 4 attributes together forming the address. So that's why it is known as composite attributes, because it is a collection of attribute, right? Third one is multi-valued attribute. So what is multi-valued attribute? See, email and phone number. Any particular attribute or any particular column name which may have more than one values for one particular record. For example, if I talk about any person, either you or I, we can have more than one numbers. That means we can have more than one values for the phone field. So this is a multi-valued attribute. Email also, we are also using 3 to 4 email id, like we are having one professional email id, one personal email id, so we are having multiple email ids for one person. So this email is also a multi-valued attribute. Now what is this derived attribute? This derived attribute is those attributes which are not generally stored in the database, but this particular attribute can be calculated and can be identified by using some attribute which is already present in the database. So for example, if I talk about this particular age, let I am having a field as date of birth in my table, right? So if I am having the field as date of birth, so I can easily find out the age, and if I subtract it by the system date, we are having some data in our system like today's date, and from today's date if I subtract the date of birth, it will be giving us the exact value for this age. That means this age can be derived using the date of birth attribute of a table and the system date. So that's why this is known as the derived attribute, and it is represented by dotted oval symbol, right? So this is how we show the derived attributes. Next is entity. What is an entity? So an entity is a real world object. That means anything which exists in this particular world can be treated as an entity, and that can be easily identified. If I talk about a particular product like a bottle, a mobile, so this is a particular entity. If I talk about a company, this is a conceptual identity. So an entity can be real world object or the conceptual. So if there is anything which is having conceptual existence, this is also a entity, like car, house, or a company. So how it is represented? It is represented by a rectangle symbol with the name in it. So this is a entity, employee entity, or we can refer it as a table. So this is a table. Employee is a table name. So always we try to show the tables in the form of entities, right, in the rectangular form. Now let's see few more things in this chapter, which is relationship set. So what is the relationship set? Relationship is represented using the diamond symbol. It defines the relation between two or more entities. So it is represented by diamond symbol. This is the symbol, and this symbol shows the relationship between the different entities, right? Now let me show you one thing. See, if there are two entities and they are relating with each other, then it is known as binary relationship, because two entities are having a relationship with each other. Similarly, if I am having three entities and three entities are relating with each other as having some relation among them, then this is known as ternary relationship. Similarly, if there are n number of entities, so if there are n number of entities, then it will be said as N-ary relationship. So on the number of entities, the value or the name will be changing. Similarly, if there is only one, so if there is only one entity, like I am having some entity as E1, and if this particular entity is relating with itself, so if this is the case, this is known as the unary relationship, right? So this is how you can identify the relationship set. Now let's see, this is an example of the entity along with the all types of attribute. So we know that this is a key attribute, This is a composite attribute, this is a normal attribute, this one is a derived attribute, this one is a normal attribute, and this email is also a attribute which is multi-valued attribute, because email can be more than one for a particular table. Now how you can find out the functional dependencies? See, here I know that employee ID is the key. That means it will be able to identify each other, all the records of a table uniquely. That means employee ID can uniquely identify name, right? It can also uniquely identify date of birth. So I can write date of birth also. Employee ID can also easily uniquely identify PAN ID, right? But here I am having email, that means it is a multi-valued attribute, and you might have remember that we show the multi-valued attribute by two arrows. So this is how I can show the multi-valued attributes. Here you can see this PAN ID. So this PAN ID is an attribute key, that means this PAN ID can also uniquely identify the employee ID. So this is how you can form out the functional dependency set. Now let's see this second example. So in the second example you can see that I am having a particular ER diagram. So this is a ER diagram with the attribute shown in the oval symbol, right? Now I just want to let you know that how the table for the relationship is formed. So for student, let I am having the table as student ID and name, right? So let the student ID is S1, S2, S3 and S4. So this is a table for student, and let the name are A, B, C, D. And in the course I am having the table as course ID and instructor. So see, this is a key value, that means it should be unique for all the different records. So here you can see that I took the student IDs which is not repeated, that means it is unique. Similarly here CID has to be unique, so I'm taking it as C1, C2, C3, and instructor can be XYZ. See, we do not bother about the name and the instructor. So what will be the key for this particular enroll relationship? So this is having, there are two tables, and this is particular enroll table. So there will be a table for enroll also, where we'll be taking the key of both the tables or both the entities. So here one key is SID, one key is CID. So I will be taking it as SID, CID, and one more attribute will be there, which is fee. So this fee is nothing but the descriptive attribute. So this also describes some of the attributes, so some of the information. So this is known as the descriptive attribute. So this is a particular table. Now see, so how many foreign keys are there? If I'm having these attributes, how many foreign keys? So this SID will be referring to this particular student ID. So this is one foreign key, and this CID, course ID, is referring to this particular course ID. So this is one foreign key. For this particular relation I am having three tables and two foreign key, right? If it is one-to-one, so we will be understanding the one-to-one and man-to-one mapping in the next video, along with some examples that how many foreign keys are required for one-to-one, for one-to-many, and other relationships, right? So here we require two foreign keys. Now see, if I'm having S1 here, this S1 has to be related with any other one. So you can see S1 is enrolled in C1, S1 can also enroll C2, and this S2 can enroll C3. So here you can see that this SID and this CID is not unique. So we can we say that the complete SID and CID will be treated as a key? Yes, we can see that, but the number of keys of this particular enrolled table always depends on the relationship, right? Always depends on the cardinality, whether it is one-to-one, many-to-one, or is there any total participation or partial participation. So in the next video we'll be understanding the participation, that means whether it is a total participation or partial participation, along with the mapping, that is one to one, many to one, and many to many. So in the next video we'll be understanding these things. So if you found this particular video useful, like this video, share it with your friends, comment your feedback in the comment section, and if you are having any suggestions, you please mention those suggestions on this particular comment box, so that I can make much more better videos for you. So if you have not subscribed to the channel, please subscribe the channel and press the notification icon for the latest update of the newly uploaded videos. So thank you very much for watching. Keep supporting, keep learning. Have a great day.